Amazon thinks the future of data centers depends on a technical problem. The old approach just got more expensive. The practical edge now comes from changing process, timing, and tooling together. We will map trigger, incentive shift, and downstream impact before the close. It wasn't a chip shortage. It wasn't a power grid crisis. It was thermal architecture, how to cool down densely packed AI servers without the infrastructure exploding. Last week, they solved it. And that solution just became the roadmap for every hyperscaler building the next generation of data centers. Here's why this matters right now. AI training and inference consume insane amounts of electricity. A single cluster of advanced chips can dissipate more heat than a small city. The problem was simple in theory, nightmarish in practice. You stack GPUs tightly to reduce latency and costs, but the heat density becomes unbearable. Traditional cooling, air handlers, chilled water loops, the whole legacy setup, can't keep pace. Data centers that don't solve this hit a thermal wall. You either spread servers out and waste space and power, or you pack them tight and watch temperatures spike until silicon starts degrading. Amazon's breakthrough is focused on liquid cooling at the chip level, not just the facility level. Instead of cooling entire racks after the heat escapes into the air, they're moving thermal dissipation upstream, directly at the processor. This reduces the energy footprint of cooling itself, which is typically 30 to 40% of total data center power. If you cut cooling energy by half, you've just made AI infrastructure economically viable at scale. More compute per watt. Denser deployments. Lower operational costs. Why now? Because the economics of AI training have hit a wall. Companies are spending hundreds of millions to train models, and the hardware payback period is shrinking. Better cooling efficiency means you can train models faster and cheaper. That changes the competitive dynamics of the entire AI arms race. Companies that figure out advanced cooling first get to train larger models on tighter budgets. That's not a marginal advantage, that's a decisive one. But here's the second angle nobody's talking about yet. If Amazon has solved this, Nvidia, Microsoft, Google, and Meta aren't far behind. This isn't a proprietary breakthrough that locks in Amazon's advantage, it's a technical shift that the entire industry will adopt within 18 months. The real winner is whoever figures out how to industrialize it first and ship it at scale. That's why this matters to investors. It signals that the next phase of AI infrastructure investment isn't about buying more chips. It's about solving the engineering problems that unlock better chip utilization. For hyperscalers, the implication is clear, the data center bottleneck just shifted. It's no longer thermal architecture. It's power delivery. You can cool a dense AI cluster now, but can you get enough electricity to the building? That's the next problem. Grid capacity, transformer capacity, power contracts with utilities, those are the new constraints. Companies that can secure reliable megawatt-scale power will win the next wave of AI infrastructure build-out. In India, this has a specific relevance. As cloud providers build regional AI data centers for local AI services, language models in regional languages, localized recommendation engines, cooling efficiency directly impacts operational margins. A 30% reduction in cooling costs means cheaper compute for Indian startups building AI products. That cascades into affordability for students, researchers, and SMEs. The infrastructure gets cheaper to operate, prices drop, access widens. For creators and researchers, this is instructive. The narrative around AI scaling has been about chip availability and training capital. This breakthrough reminds us that the unsexy problems, thermal management, power delivery, facility engineering, are often the real constraints. The winners in AI infrastructure aren't always the ones with the best chips. They're the ones who can run those chips efficiently. Watch the next 30 days closely. If Nvidia and Microsoft announce similar cooling breakthroughs, that confirms this is an industry-wide shift, not an Amazon advantage. If Amazon stays quiet and builds in silence, they might be trying to hold on to a structural edge. Either way, the data center industry just entered a new phase. The problem that was invisible to most people last month is now visible to everyone who builds on cloud infrastructure. That's worth paying attention to. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next. Watch the execution timeline, second-order market effects, and policy response to gauge what happens next.